Hello, I'm Jaime Emmanuelli, Managing Partner for Hive Plasma Lighting from Los Angeles, California. Here just to tell you a little bit about what we do at Hive. It's a new technology that we've developed called plasma lighting. Plasma lighting is greater energy efficiencies of LEDs with the output of HMIs. So it's 50 to 90% less power consumption. Bulb life is 10,000 hours, even though the bulb will actually last 30 to 50,000 hours. We recommend you change it after about 10,000 hours. We can guarantee the color temperature and the output for the first 10,000, and then it will shift a little bit bluer, about 500-600 degrees after 30,000 hours, which is still usable, still 75 to 80% of the output still. This is our bulb, which is just one single small capsule. It's electrodeless, there's no filament, that's the reason why there's nothing to degrade. And what we do is we have inert gases that are inside here, a proprietary mixture. Some argon, some krypton, some metal salts. The gases in here are excited by radio frequencies. Nikola Tesla invented it about 130 years ago, and we took about 3.5 years to perfect it for our industry. So what we do is we blast this capsule with a ton of radio frequencies that excite the gases, creates an explosion, and turns the gases into a plasma state. So all of a sudden the gases start to spin like the sun or a star does and creates a lot of photons. It is a true 94 CRI. We are one of the few companies that actually, on all of our literature, we actually publish our spectrum. We're very proud of it. It's a full spectrum light. Most lights run at 50, 60 hertz, and some of your ballasts up to 1,000 hertz. Our lights run at 450 megahertz. So it's truly flicker free. So in other words, you can shoot up to 225 million frames a second with zero flicker. It's about 90 seconds from cold start. From right when you turn it on to full output and color temperature is about 90 seconds. It's similar to an HMI where there is a restrike time. It depends on how hot it is outside, the ambient temperature. It could be 10 seconds, could be 2 minutes. We shot a BMW commercial on the hottest day of the year in California, in the California desert. It was 115 degrees, and the lights were in the sun, and they're obviously black. Color, and it ran for 9 hours. We turned it off, turned it back on. It was about 2.5 minutes before it came back up. So it's usually about how hot it is outside. There's about 1/4 of the UV of the bare bulb of an HMI, but as soon as we put our safety glass, it cuts all the UV out. So there's no UV problems at all. You would treat it like you would any other lamp. No, it's not waterproof. If you're out in the rain, all the components inside are sealed. The bulb itself does get very hot, so you don't want to put water right on it because it's quartz, it's glass. But if you're out in the rain and it starts to rain heavy, just throw a cover over it like you would an HMI or any other unit. Well, when you look at having to change bulbs, you're looking at changing a bulb. Average comes out to between 5 and 8 years before you change a bulb, up to about 15 years, where tungsten you're changing it a lot more often. HMIs are rated at 300 hours. For most of them in our world, and every manufacturer suggests that you change them at 50% life. So you're looking at a 150-hour bulb as opposed to a 10,000-hour bulb. It loves cold, so you can go minus 40 Celsius up to about 115 degrees Fahrenheit. And like I said, it's about the ambient temperature. So if you get up to about 115, 120 degrees Fahrenheit, just throw a fan on it. So as long as there's some airflow going through it, it'll be fine. It has everything inside to protect itself. So if it turns off, if it's too hot outside, you're not going to hurt it. You can go ahead and flip the switch. When it's ready to come back on, it'll come back on. It's actually the only light that's allowed to be used on a commercial aircraft at 10,000 feet. And you can actually shoot on an aircraft at 10,000 feet and can be flown as luggage or whatever for up to 35, 40,000 feet. There's less than 10% of the radio frequencies come out of our light, 10 times less than the cell phone in your pocket. So there's no interference with microphones, lavs, nothing on set. So basically in retrospect, so it's a plasma, it's not LED, greater energy efficiencies than LEDs, the output of HMIs, 10,000 hour bulb life, full spectrum, high speed up to 225 million frames a second, 1/10 of the heat on it as opposed to other lights. Solid state, so you literally cannot hurt the light. There's no maintenance to whatsoever, DMX control, so you can turn it on, turn it off, and in and out of the low mode. Run it on batteries, 18 to 38 volts DC anywhere in the world. So it's very energy efficient, a lot of output, great quality of light, which is what we're most excited about. This is our WASP Plasma Par. All the units are completely solid state, so there are no moving parts. They're completely silent, no fans, and as you can see, there's really nothing that you can do to hurt it. I mean, you can't hurt this light. I mean, you can move it while it's on. There's nothing to break except glass, and glass is inexpensive. And it's a native 28-volt DC system, so you can run our single units off of batteries. Any battery from 18 to 38 volts DC anywhere in the world will run this light an average of about 2 to 3 hours depending on the amperage of the battery. But the other great thing we have inside is that we have voltage regulation. So when your battery starts to deplete the charge, most of the time the lights start to dim and change color. Well, with our voltage regulation electronics in there, it keeps the battery output exactly 28 volts to the lamp. So even if it goes below or above, it's always 28 volts, so you always are at 5600, always at 94 CRI, same output all the time through the life of that charge. So you never have to worry about after an hour it being on, it being a different color temperature. It'll regulate it automatically. It can run AC with the power supply, 100 to 277 volts anywhere in the world, even dirty power. It automatically self-regulates to exactly 28 volts. We have a low mode. I'll turn this around here. So when you push this button here, you turn it into the low mode. Right here, it'll say low. It reduces the power by 50%, 25% output, but it shifts blue. So it goes about 13,000 Kelvin. We initially did that, you can see how blue it is now. We initially did that so that if you were running on batteries, your batteries would go from 2 hours to 4 to 6 hours in length in between takes. Or if you're on a set and in between takes you just wanted to conserve power, or for hot restrike, then you come back here, you hit the button again, you bring it back to high, and you're in full color temp and output in about 4 seconds. The total system is 276 total system watts. The bulb itself is only 180 watts, but some other companies will say, well, it's a 400 watt, but you also have a ballast, you have slimverters, you have other things that consume power. So with all of our electronics, it's 276 total system watts. But the other great thing, it's so efficient, it's actually only 2.3 amps in America. So here it would be just over an amp for a single unit, where a 400 watt par, in some cases, are drawing upwards of 6 to 7 amps instead of being 4 to 5 amps. So it's very efficient. I can plug 7 of these units into one 20 amp circuit. Yeah, that one is what we call our Killer Plasma 2-Light Maxi. 540 total system watts of power consumption, equivalent to between an 800 and a 1.2K HMI, depending on the brand. Some companies have really, really good glass, and so we're about an 800 with them, but for most companies we're equivalent to about a 1.2K HMI. Then it's a modular system, so you can actually take 2 of them, put them in an accessory frame, and make a 4-light. This 4-light's drawing 1,080 watts, equivalent to about a 9,000 watt maxi that you would have to turn blue to daylight, or about a 6-7K tungsten or a 2.5K HMI. Drawing 1,080 watts, no ballast, everything running off of stingers. You can plug 4 of those into one 20 amp circuit here in Europe, being that you guys are running at 240. It's a whole lot of light for very little power. No more need for generators, great for location work. Great for high-speed work where you need a lot of light, the higher frame rates you use, because you can also get the light really, really close to the subject. When you're shooting high speed, you need a lot of light. So you don't have to worry about it burning subjects, burning people, burning food. A lot of times they're using our lights now for all the high speed with Easton Sports, where they have to get really close, a lot of light, but no more generators, no high power, no heat. There's no ballast, so you don't have to worry about ballast. There's no maintenance. Bulbs last pretty much forever. But the other great thing that a lot of people like is that you can actually grab the glass. It doesn't get hot. You can touch that and see that's about as hot as it gets. It just gets warm. Standard accessories on this, so we have 6 5/8 inch or 170 millimeter barn doors, lenses that you would use on any of your competitive 170 millimeter par lenses. So if somebody is out shooting somewhere and they break a piece of glass, they can go get one at any rental house, put it in the frame and keep going. You also have, for dimming, being that we don't dim, because when you dim, you saw we shift really blue. So you would just use your standard scrims as you would an HMI. So you have your scrims. Then, being that we use standard size ears, you can use your 170 millimeter speed rings, so you can put your Photoflex or Chimera soft boxes on it. You don't need the real deep ones because they're deep because of the heat from the lights. So you can use your photo ones, the short ones, to get in smaller areas because there's virtually no heat. So this is our, like I said, this is our WASP plasma par, equivalent to a 400 watt HMI. We have our killer plasma 2-light maxi, equivalent to a 1.2K. You can also, like I said, turn it into a 4-light maxi, which will give you your 2.5K. And then we also have our drone, which is a Source 4 LECO retrofit kit. So you can actually turn your Source 4 into a plasma Source 4 for basically half the cost of what it would cost to turn into an HMI Source 4. It takes about 10 minutes and you have a plasma Source 4. All the single units from the Fresnel to the PAR to this can run off of batteries, 18 to 38 volts DC for hours. We also have a Hornet plasma Fresnel that's coming out in about a month. That one is the same 276 watts of power consumption, fully focusable, like your standard, like a 575 HMI Fresnel. Greater output than a 575, but again, cool to the touch, half of the power. It's a minimum of 50% less power consumption than an HMI, and up to 90% less power consumption than tungsten. Thank you.